barrier. It was treated as a barrier. Nobody ever thought you could break the barrier. Even Chuck Yeager was worried when he got into his flight path to break the sound barrier. But the strange thing is, if you look at the drag and you plot it as a ratio of velocity over your speed limit, which c here represents the speed of sound, you get a nice curve whose equation matches exactly what we're faced right now. Exactly the same equation for superluminal or subluminal flight. Right now we're in the subluminal flight mode. Every textbook on relativity tells you, this is what you memorize, this is your speed limit, and you can't go faster than the speed of light. Nothing can go faster than the speed of light. And of course, then there's another equation which describes the drag constant. And you get the same type of buildup in the fluid medium that you do for sound. And this to me also was very fascinating because this equation here, if you can't read it too well, is also reproduced over here. And once again, we're looking at permeability and permittivity. Now, as we look back on the previous slide, which I might as well, since I've got lots of time here, is to go back a few slides here. Whoops. Maybe I won't go back. Okay, good. I'm stuck with a little arrow here that I'm not sure what it means. Well, I tried to go back and I shouldn't have. Help. Just if you can remove that little gray box there, because I'm actually pointing to it. Oh, I got it.
This toggles it from a mouse to a page up, page down.
Okay.
So page advance, page read. Now you got it.
I'll stay where I am. This is good enough. But previously we did mention that the temperature dependence and impedance was directly related to permittivity and permeability. And now we're seeing it once again pop up as a very important parameter. Now the Lorentz force compared to the zero-point field, this is actually an outgrowth of Puthoff's work. Puthoff's work is now being applied to this particular experiment. And Einstein-Hopf drag is exactly the analog in the light mode, as you see with the aerodynamic drag in the sound mode. And so what is exciting to me is that when you talk to people at the DOE, for example, Dave Hamilton, who runs an electromagnetic talking group, a very interesting scientific exchange group, which is mostly internet-based, you find them talking a lot, even as the Bearden group does as well, on non-abelian electromagnetic fields. And essentially that mouthful basically describes a non-commutating field. In other words, if you multiply A times B, it's not equal to B times A. And if you allow that non-commutation to apply, you get a whole new physics. And that little change means that order is important as you apply fields and as they're multiplied. And also, of course, the other important thing here is the toroid. Fronig's work basically was at the Joint Propulsion Conference just a couple of years ago, 2002. And that number is 3925. So this paper is actually available from AIAA, and there's a library also that gives you hard copies or soft copies. And there's also some description of it too, but let me just skip ahead to the next slide and show you a picture of how it works. Oops. There we go, one more. Here's the Fronig's concept of the superluminal saucer. And let's see if I can point out a nice, interesting quote that he points out too. The non-abelian analog basically allows for the forces, essentially the resistance representation R can be changed by surrounding the saucer-shaped starship with a toroidal electromagnetic field that distorts and perturbs the vacuum sufficiently to affect its permeability and permittivity. The vacuum perturbations are simulated by fluid field perturbations that result in the percentage change of the disturbance that basically allows for a big improvement and a reduction in the drag. And this is probably the most important part. In other words, so far whenever we've considered moving through a vacuum or moving through a medium, you're always concerned with how the medium interacts with the vehicle. So far, as I explained before, the vacuum is treated as an empty vessel. So we never think of the vacuum as resistance. But inertia proves that we do have resistance, and even gravitational forces also show that. So what Freundlich did here was to apply the fluid dynamics laws and perturb the vacuum with a toroidal electromagnetic field. And for those of you who are not familiar, a toroid simply is taking like a solenoid, a coil of wire, and winding it together to form a donut. So as you form the donut, the magnetic field's inside internally, and the A field, if the donut's, say, in my hand, the A field, the vector potential, is vertical. And it's a very unique field. There's lots of properties of the vector potential. And here's another good example. And if we allow for the temperature to basically approach absolute zero, wouldn't you know the nice coincidence is that the outer space temperature is around 3 degrees, absolute zero. So we have a very convenient enhancement of this phenomena by going out into space, which we cannot get when we're close to Earth. And of course, you get this accelerating recoil. And the other special bonus is it transfers energy from the ZP field as well. And that's perhaps the most surprising conclusion, is that you not only get this motional effect of force, unidirectional force, which he's trying to show here. This is actually a 1 over, it's a minus, so we're seeing a reduction on both sides. And so the vehicle is being pushed in one direction based on the negative perturbation of the vacuum field. So far this is in the conceptual mode, but the nice thing is the physics has provoked enough people to consider putting it in the experimental mode. Now another experiment that is perhaps, nothing can get physicists more irritated and upset than basically say that we can get energy from a single heat bath and we don't need a temperature difference. Because what they basically think is that you're violating the second law of thermodynamics. Well, as a matter of fact, they are violating the second law of thermodynamics. And it's been in Science magazine in 2003, just last year. And it's also providing a lot of controversy. And of course, this is a big pillar of defense that's being collapsed now. And it caused a lot of exchange of letters and responses to the editor as well. And in fact, let me read the little description. And this is from a similar author who actually predated Scully's work, and he describes even more of the violation details. For example, the Casimir, the analysis of the Casimir engine cycle demonstrated a departure from the hydroelectric gaseous, that's in our next approach. This is our photo Brownian photon and Carnot engine, and what the Alavirden points out, and I'm happy to say this was brought to my attention from the Binotech conference a couple of years ago in Germany, whose some representatives are here today. And what Alavirden points out is that our main results are rather dramatic, apparently contradicting the second law. We show that the Clausius inequality, which is dq being always less than temperature times the difference in entropy, can be violated. And that it's even possible to extract work from the bath by cyclic variations of the parameter. And they even throw in, parenthetically, a perpetual mobile, perpetual motion device. And the physical cause for this appalling behavior will be traced back to quantum coherence in the presence of a near equilibrium bath. And it's emphasized that quantum coherence is reflected in the quantum noise correlation and so forth, more technical details. But the most important part is that we're literally describing something that's very similar to a micro laser cavity. That's literally what we're looking at here, is a micro laser cavity. And all we're proposing is this unusual phrase called quantum coherence. Well, that simply is a phase difference. And if you allow for a phase difference, you can then have a temperature difference internally that basically rotates or circulates radiation. And so radiation essentially is the medium to drive the piston. Radiation pressure